Thanks for joining us. I think today we'll have a bit of fun with data science and how to move beyond experimentation. I'm curious who in the room is familiar with data science? Okay, we have some people that are familiar, some people that are not familiar. I think we'll have fun. We'll talk about it. And it's worth mentioning we have an interactive session, ask questions, challenge us, because that's why we are here. I'll start by introducing myself. I'm Andreea. I'm the AML product manager in Canonical. Usually I host these workshops on my own, but today I have a special guest who's Kimonas. Would you like to introduce yourself?
Hi, folks. Nice to meet you all. Like, maybe it's that time for LinkedIn. Okay. So yeah, I am the MLOps engineering manager for Canonical. I have a small attention span. So after I finished my uni courses, I really was into okay, what's hot? It was super hot to do ML and AI for any uni undergraduate, but I really was curious on this Kubernetes thing. So I went to one of my professors and was like, "Hey, I want to do ML and Kubernetes." And he's like, "Oh, it's your lucky day. We have a company that want to invest in this. So would you like to start with Kubeflow?" So it's like, "Yes." So here's some jQuery we need you to write with some front-end code to get started. So thankfully my ADHD helped, and from front-end we went to back-end, we went to Kubernetes, we went to webhooks, and after some time, Kubeflow was really something I was fully enjoying and have ended up being as part of multiple working groups. And that's actually what then ended up as a follow-up to come up to Canonical to keep being able to both push get the feedback from the community on the MLOps from Kubeflow that aims to do ML on Kubernetes. So we can combine this with both Canonical's tooling to automate even this process that we will see in a sec that is a lot of very difficult to manipulate different components together. And that's why my hair fell. So this.
And if you didn't understand all the things that Kimona said, all the technical terms, don't worry. He will have to explain all of them. On my end, I don't have any experience with K8 or building tools. I would rather use them, and I have a data science background, so I'm the one that challenges him always to have friendly and actually user-friendly tools that people, organizations can use. In case you're curious, it will be a hands-on workshop, actually, so I'm not sure how many of you have a laptop. Okay, I see many laptops. Cool. Then that's good. We'll start by talking a bit about the machine learning lifecycle, MLOps in general, then about Kubeflow, and in the end, Kimonas is going to guide you through all these difficult things that we are doing. They're not difficult, I'll have to say. What is MLOps? What is MLOps?
Machine learning operations.
Good catch, Juan Luis. What is machine learning operations then?
Business term you make up like some years ago.
Ouch. I'll take it. Okay.
Like anything else, software, just can't manage to solve it once. So we need to have a whole life cycle before we can use.
Yes, I usually define it as DevOps, but for machine learning, it's quite a new term, that's true. And I think there is still a lot of debate on what it actually is, what it actually does, if it's really needed or not. It's split into two important categories: machine learning, which is what most of data scientists, machine learning engineers enjoy, and then the operations part, which is just the part that we have to do in order to ensure that actually our projects can run in production, are maintained, they don't do any damage to the society, and so on. So let's look inside MLOps. That's what Kimonas says. So it's all about prediction. Kimonas, what did you want to say here?
Damn, you took my punchline. So for me, when I initially started and seeing the term MLOps, it was really, really confusing to find a way to start from somewhere. So I'll try to guide you through how my understanding of MLOps happens in terms of priority and how we get there. So at least initially for me, the initial question for always starting is, okay, you have MLOps. What at the end of the day, what is always the final product? What is the thing that actually we aim to produce out of doing MLOps practices? Any takers?
It's all about predictions.
Ho, ho, ho. You just want your first candy. so so do you have the yes, as Theodora nicely mentioned, it always starts by the end goal that we need to do is be able to do predictions where a simple example is we have a banned transaction and we want to know, is this suspicious, where this weird model is most probably going to go and get some data to find like some information like, okay, what were the last 20 transactions, where was their location, and then with the new data that it just got, like these transactions happened then in this location, it responds with yes or no. So MLOps is all about being able to is the value of MLOps is being able to do this at the end of the day, to take
See some yes, I see some.
Very good question. So that thing is actually a server. It's a live thing that runs and gets requests. And to get slightly more into that, it actually has a transformer component. You can even think of this as a distinct dedicated process of itself that gets the data from the need that we queried the server with. Then it's gonna fetch some data from our from a cache. This usually is some Redis fast storage to get like the quick data it needs, and then it will send this data back to this mysterious model thing, which again you can think of it as a live process, which will then with this data will go and give you the final prediction. So this in Kubeflow of course is Kaiser, but we'll also be seeing this in a second. So at this point we are defining what a model server is. And what I want you to keep in mind here is that the model server is actually a live thing. I really hope that those are some of the questions that you had in mind, at least from the initial, until this point. Like, okay, what is it? What exactly is a transformer?
Kimonas, take a breath. I'll stop you here. What questions did you have in mind?
What's a transformer?
Thank you.
That's weird.
Yeah, I don't know what that is. I know what the rest of it is.
Really?
Yeah, it's a neural net. I know exactly what it is.
Anyone knows what transformer is? What is it?
It's a neural network architecture, right?
Oh, no.
Yeah, it's a sequence-to-sequence model with an interesting technique and optimization inside to make it run well on invented by Google TPUs. But at the end of the day, the the underlying mathematics is the same as any other neural network. It's just an optimized version that can train well. For what? That was the name that they gave them.
It's like a pre-prompt, and then it's like that you might normally use business like
That's exactly what it does. Because since this is a server, it will take whatever request you're sending to it, and as you mentioned, make any necessary pre-processing so that this data can end up to the model the way that the data will expect the model.
normalized vectors.
Or potentially reach to some other small fast access storage that has some extra data that the model might need. For example, my initial request might give you information, my bank transaction happened from Kimonas on that date, but the model, in order to predict, needs to know, okay, what were the last 30 transactions? So this component will actually go to this cache to get this data and end up fetching it to the model.
Yes, here if you want.
I actually have a very practical question. In my experience, having transformer, separated from a model was always a large headache in operations. Because you have one transformer, another and model trained on a different transformer, and you're pretty much screwed. So how do you address that?
isn't the answer always to that microservices?
Oh, don't get me started about microservices.
But I agree. If you can avoid it and keep it simple, yes, that's the preferred way. But there are some cases where we're seeing where we might need to talk to other components, either like Feast, for example, to fetch some features where this logic might be needed to be on its own component.
Maybe, maybe in connection with that, maybe the transformers that you're talking about don't fit on a machine. Don't fit on a single machine. Usually, you need GPU power or something. You know.
Yeah, I think. I mean, I can easily talk maybe at the end of it from about MLOps from the product angle and how do we actually get there and why we do need GPUs maybe. But also, I think that for experimentation or for small projects, you can survive without them if that makes sense. Kimonas, do you want to go back to your model servers?
Oh yeah, but actually, it's super nice that we see people that actually are very familiar with that. So the other questions that any other question actually that arrive, I'm really ready to go on how to create a model and what this small thing is, but I don't want to really jump the trigger if someone else has something that wants to ask on that.
Your questions?
I guess one question when I was talking to you, so when you talk about transformers getting data, like they get a request and that doesn't necessarily, it's like business request type of data it's getting. And then you said it goes back to, let's say, Redis cache. Does it ever also make requests to like the business database, like to collect more data for a specific request? It usually only data comes in from these requests.
It all depends on how fast you want the inference to happen and where this data will live. That's why in some case Redis, which is a cache, is way faster and you might want it. But if you can live with waiting 4 seconds for your request to go to the whole data lake to fit data, that is an option as well.
I think it really depends on the end use case or the problem that you're trying to solve with MLOps at the end of the day.
And just a clarifying question, are you talking about training or inference?
Hmm?
Inference or training, or both? Inference. Got it.
So to continue on this nice discussion, the question then is, how do I create the heart of this server, which is the actual model? And this model is actually something simple, at least to look at from a management point of view. It's just a simple file that can have multiple formats. It could be, depending on the framework, an H5 file, a PT file, a simple PKL from Python, or a single binary for.
You can take this.
Does it work? Oh, or a simple binary that we, at some point, because it's binary data, we always end up storing into some S3 like 90% of the time. So with this information as well, our conceptual model now slightly transforms into a model server is actually a component that runs potentially a transformer, and the actual model that needs to be fetched from an S3 whenever it gets started. Which, to the back of your mind, you can think of, okay, then I need credentials to access S3, and this server will need to have access to those. And this is the live model server. So then the next question, to get slightly into more detail, is for creating a model, which everything, as you can expect, also starts again with data, where this can be a huge data warehouse. Actually, how many of you have created a model that started with like huge terabytes of data? I'm curious to see what are your practices there for your data store and lake? And yeah, it looks that way. Seth? Okay. Are you using also some Rados gateway, having converted to S3, or just Ceph for replication?
S3 on Amazon is totally too expensive for us. We run the brand.
Super nice. But Ceph, for those that I think everyone knows, but it's a way for you to also have replicated storage. So, and it's like the de facto for on-prem, as you mentioned. Just keep in mind, I think I realized this recently. There is a way to run S3 functionalities on Ceph. So this could be something to. So back to creating to the whole process of creating a model. Everything starts and ends with the data, and this is a small spoiler for later on. And the next thing is we define our training code that will fetch this data to run a model to train on, most of the times on GPU. And then with some glue code, which most of the time is Python, this artifact, which is a model, which as we previously saw is a file, will need to get stored with all of its metadata. And this metadata usually contains both information like the performance of the model, the characteristics of the model, where was it trained, when was it trained, and always a pointer to where the actual model is then stored, which again usually is an artifact storage in S3 most probably, because as we saw, it can be a binary format, so we cannot store this to MySQL. So I know this might seem pretty straightforward or basic, but Phil, at this point, if you have any question, also feel free to interrupt me. Go.
So, like, I've heard of, like, I guess recently, like, Cloudflare has this, like, runtime, you know, as far as this MLOps, like, there's now platforms that are like platform as a service versus, let's say, you know, doing all this, like this. Have you heard of the Cloudflare, like, Onyx runtime?
Oh, Onyx, yes.
Yeah. So, if you're, like, having a larger company that's, like, making its own everything, since everything is the custom, would you ever use something like these? I mean, maybe at this point, maybe in the future, going to move the platform to the service, and it's going to be all whatever serverless type of things. But is that a thing that is being used that you see, like making things for like a portable runtime like Onyx that like you can deploy on different? Is that a thing yet at all, or is it just sort of? Have you seen it? I don't work in the field.
I have questions for Onyx exactly on how do you mean that this will need to be run multiple?
I mean, I haven't used it in Cloudflare. I've used it like their platform as a service to run app.
I think, sorry, I'll take this question from a product perspective. I think that there is a journey. You usually start with very manual processes. You don't need a platform as a service or anything like this. You just need probably a Jupyter notebook or whatever. And then usually companies move towards MLOps platforms, and MLOps in general, when they're ready to scale their projects and to experiment more. And that's when they look at different capabilities and ways to actually automate most of their processes.
Yeah.
I'm not sure if that answers your question.
Versus like this versus when you are deploying.
And it is used because that was also a question. Hey, do you know if it's used? Yes, it is used, but it's not used at the beginning. I talk and we talk to a lot of companies, and usually they're like, hey, we want to start with AIML. And that's when we don't recommend, hey, get this fancy platform, invest a lot in GPUs. It's fine. You can start on a public cloud, for example, or you can start on whatever infra you already have in-house. But then once you are happy with the experiments, you know that you have enough data, you have some models that you're happy with, it's worth investing in an MLOps platform, and it grows. And actually, it's nice because that's what we will talk about, and you'll be playing with an MLOps platform.
I have some questions coming your way afterwards, though.
I think by 10 o'clock, you'll still find them here.
Oh.
Go for it.
So, and of course, the important piece is that this model code that will train on a GPU and then the logic to push on a store, this can happen in multiple stages, with multiple phases. It can either happen from inside the Jupyter notebook, which someone will just need to experiment a little bit, just play around, find what works. And then once we have something that we feel comfortable with most of the time automate with some pipeline some pipeline system that can replicate the logic that we had to be able to redo and retrain and create multiple versions of a model. And
so how do you create a model again?
That's a nice question. So it all starts with the data, whether it's S3, MySQL, or Ceph.
What if I have data that's images or videos, Kimonas?
That's data in MySQL, S3, or Ceph.
Fine.
Which we then we'll need to have our code. But the thing is that with those huge files, we need to break the training can be more tough because it's huge data set on how to break it down and have maybe distributed training, which nice. We have our framework logic, PyTorch, TensorFlow, Paddle that can do distributed training as we.
What's Paddle? What's Paddle? No, I ask all the questions that I ask him usually in our meetings. it's very easy for me.
Paddle is something that blew my mind when I read it, and I think everyone should try to take a look. It's a really nice way and efficient of training models, and it's actually getting traction in Kubeflow as we speak. So yes, but and you can use it also for inferencing and for training your model. So and of course, the crucial part is that all of this training will need to happen on GPUs because a ton of data, and we need to save some time. So the question at this point that I briefly touched is, at least I'd like for everyone to be in sync with a notebook via a pipeline. And the pros and the cons are, for notebooks, it's always easy for people to experiment and try different libraries and code. Actually, I'm pretty sure, is there anyone that haven't touched ever Jupyter Notebook here? Never?
No, never.
Wow, I envy you. So it's always an easy way to experiment and to be like very suitable for playing with some small data and being able then to see what works and what versions you need, etc. But the problem if you haven't run one is the fact that it's not as linear as a simple Python script, because you can actually run whatever cell you want in whatever order. And while it's super fun to play around and get something that works, it's not the best reproducible way to then, if you have something that works, to go to production and say, okay, now follow this cell, then run that cell, then run this cell twice. So that's why all of the time when we have experimented enough, we go then to a pipeline, which is an actual graph of the steps that we needed, that can be organized as a graph, triggered programmatically, and allow us to go to this services architecture where each thing is its own step. Of course, with the complexity of creating those steps. So, do you think I've missed something? At least for me, this is everything that comes to the. Sorry? How you go from a notebook into a pipeline? How to transfer from a notebook into a pipeline? That's a super nice question. We're going to see this on the workshop later on a bit. So, it depends on the tooling. In Kubeflow's case, there is a specific DSL that allows you to define, okay, so this is my code now, and the DSL has a way to describe in that Python code what are your inputs and outputs, and that DSL will then will end up creating a base container. You can define what your base image is, and take your code and inject it into that container. We'll look exactly into that how this container will end up looking, but it really is a big problem, and this is where also a lot interesting projects can happen because at the end of the day, starting from some code, and you need to end up with a container that will have that code. This is the complexity of systems like that run on Kubernetes and microservices. So to reiterate again, initially the DSL of Kubeflow pipelines allows you to write some code as a Python function, and then with Python code define that, okay, so in the end this will be run as a container base and take my code and run. But there can be other tools for that. For example, there can be also tools that allow you to build a container inside from a notebook and then end up defining the pipeline and use that other container. It's a little bit open, but that's why we try to have best practice and recommend people with examples depending on the use case.
To summarize this, transfer a notebook to a pipeline. You have to break down the notebook in different containers, then orchestrate those containers again.
Yes, but you will not break them down initially, at least with Kubeflow's way. You will not create explicitly a container. You will just need your Python code defined, and then you write another line of code that says, okay, so this is my Python function that I wanna run as a container, and the Kubeflow DSL will have a way to then, with its client, to create the pipeline and say, okay, start Python container and inject this code inside of the container and run it. So you won't necessarily out of the box have to do it, but in some advanced use cases, you might need to actually say, okay, I will define my own container, which then needs a system for you to build your container.
Let's go.
So,
Question here. I have a question. Just in addition to it, there's a that's one. Good one. So there's an additional advantage to moving to pipelines, is that when you have your notebook and you're having your fun and everything, if suddenly something crashes, it's gone. Like all the loading of the model, all the loading of the data set or whatever you did is lost. But with pipelines, you can snapshot literally what's in your memory and reproduce it and reuse it. So it's also safer for those who like to do iterative stuff. You know.
Nice. So now that we also have the concept of notebooks and pipelines, let me do a quick summary at this point because we've touched quite a lot of those. We're over here at this point where, to reiterate, we always start with data. Then we define our training process that can either happen via inside Jupyter, a Jupyter notebook for experimentation, playing around and be able to find out what my final code will look like. And this process includes having your framework code, potentially training on GPUs to end up with a model. And even during that experimenting phase, you log things on your produced models on metadata stores. And once you're pretty confident with the model architecture that you have, that's where you then switch to actually an automated way to run this, which is a pipeline, which again will need to log things to this the metadata store for its model. And at the end of the day, then you will deploy a model server that will get this from this S3 artifact storage, the actual built model, to be able to run it so that people can run predictions. So question, is that it? What's missing? Huh?
Why are we?
What?
I will not. Sorry, again.
Talk is cheap. Show me the code.
So I trained my model and I have a model server ready and running. Is it the end of the story? Am I
No.
happy for my entire life?
No, but I'm a bit afraid to throw it.
Fine tuning, testing with different data, and yeah, it's a continuous thing. It's not like we trained and we're done for life. We have to maybe keep training or keep changing the model. So yeah.
The candy will have to go to both of you. First one, though, because you mentioned slightly better. Yes, it's this process that exactly what you mentioned for training, but it's actually the piece that what you both described. Where's the data and what happens with new data, because you always have new injection and you always want to make sure that you're up to date. So with more data comes way more responsibility and problems. So we need to have a way to actually do model monitoring and be able to retrain our models, as you both nicely described. What's model monitoring, folks?
Having some metrics, metrics to see how it's performing and if we are satisfied by that. And yeah.
Man, I need to get more candy. Excuse me for a minute. Yes, that's exactly it. So with model monitoring, we always want to make sure that we have mechanisms that we can predict and observe actually the performance of our model and be able to programmatically decide if we need to retrigger the whole training process. And in the Kubeflow, at least in the MLOps world, the way this usually looks like is the following. The model server itself is configured to be able to is configured with a logging endpoint where the model server will say, okay, so I got a request from a user, I got a request that asked if this bank transaction is valid or not, and I responded with no. The model server then will get this data of this is what I had as input and this is what I produced, and gets configured to store this data somewhere. The architecture here most of the times is this is some kind of eventing queue system. Most of the time it's Knative backed by Kafka if you want to have a production ready environment, but you can have something in memory if you want to live in the edge. And the first thing that this happens is also this data then gets injected back into the initial data warehouse, because you always need to make sure that you track all of this new user data that you're getting to redo the training. But what happens at the same time is that this data also gets aggregated and collected by another server component most of the time, which is the component that does the model monitoring, which is either drift detection, bias detection, which usually it gathers a lot of these requests. Like you tell it, okay, get like 500 of those requests. And once you have 500 or 1,000 of those requests in your memory, run the mathematical algorithm that you know, and tell me if my model is actually starting to deviate or if the data that is starting to deviate from what I was expecting. And this component will just, it's a very simple yes or no component that if the answer is yes, you need to do something, it will most probably talk to a Lambda function, which again, the Kubeflow world and Kubernetes, this usually is a Knative Lambda function. And as you can expect, what this Lambda function is doing is just retriggering then the automated way we had with the pipeline to rerun based on the new model, new data, etc. So, and this is why it's very crucial that we cannot do everything in Notebook actually, but why we need pipeline definition, which can either be run like every week with the newest data or be run automatically with such a mechanism.
Use on Lambda, that's to make sure we have to be on AWS.
So that's why I mentioned the Knative, that Knative over there. This is a project in Kubernetes. And Knative has a mechanism for even scaling pods down to 0 and has a way to, so when you get a request, it will say, oh, this needs to go there. So it will spin up the pod back up, and that's why it's Lambda on Kubernetes. Oof, we did some work. Any questions? So you can be hard. It's okay. Do we know Knative? People don't know Knative. What's Knative? But that's a little bit of it. Yes, Knative, at least for me, is a very nice system for handling events on Kubernetes and doing serverless, having serverless workloads on a Kubernetes cluster. And
being conscious of time, I suggest we keep moving, but long story short, yes, it's a sort of tools that enables developers or data scientists to develop and deploy models. It has plenty of components. Some of them are here. Let's go to the next slide, maybe. Because we will also play with Kubeflow in the next couple of minutes. That's the overall architecture. Kimonas, what do you want to add about it?
There is a small extra addition, which I'll still have the question that is that all? But the small question I want to make on Kubeflow is that its initial goal was not to recreate any new service for doing ML, but rather take what's already existing and tools that people are using and bundle them on top of Kubernetes. So its goal is never to invent a new tool for people to do ML, but rather take the best practice that people have and find a cohesive way to do all those in Kubernetes. So
now I learned something new.
Oh, yeah. Wait. So yes, my question again is that all? Is all this tooling enough?
Kind of stuff you have
Super sad. Grafana, Prometheus.
Exactly. But the last missing piece is for people to keep in mind that while this is indeed the process that we do for all around MLOps, the next question is, okay, is it just one person doing MLOps or we have multiple people?
We have multiple people that answer this. So
in this case, Kubeflow will actually, and any project that aims to be then a platform because it has multiple users, will need to have extra components like a service mesh to be able to define who can talk to who, not anyone to access whatever, and also some login mechanisms so that people can actually connect into this whole platform and access the dashboards, etc. So it's big, it's a lot, but this is what Kubeflow aims to be. And this is also good time to give a small overview of like going from Upstream to Charmed.
Yes, I will not start talking about Charm, but rather about Charmed Kubeflow. It's Canonical's distribution of the Upstream project. It has the same components, same capabilities that you've already seen. And a couple of things on top of it. Observability, we already touched upon it. So it's integrated with Grafana and Prometheus, for example, but also with plenty of other tools. I can easily recall MLflow, which is another tool that many of you from the audience, I would say, love. And then it's also an enterprise-grade solution. It runs on any CADE, that's CNCF conformant, and also on any cloud, supports hybrid and multi-cloud scenarios. And Kimonas, should we make it fun from now?
I think it's time. We spent too much time with slides, so everybody has a laptop.
I see many laptops. If you do not have a laptop, maybe you can team up with someone who has a laptop. It's also a great opportunity to meet new people.
That's true, actually. Yes, we could group people this way.
Let's see. Okay, so what are we gonna do for the demo?
So I'll give you a disclaimer. We'll try to be wine experts, try to find predictive if the quality of a wine based on some characteristic like its acidity, its pH, etc. To be honest, it's a quite simple model that will even run on CPU, so don't expect something huge there. But the value that I hope you will get out of this is to be able to at least have an overview of all of the Kubeflow application that we'll use to be able to produce such a model. We'll learn how to play around with notebooks, and then how the whole life cycle of a model to create it, track the different versions of it, and to also deploy it look like, both from a notebook, but also from a Kubeflow pipeline.
Let's see how much you have time to do, though.
So if you're all ready, I think we can kickstart this, and I will need you to do two things. The first one is I want you all to connect to this IP, which is the Kubeflow VM that we will all share and run the tutorial from. So there should be an initial question. I want to see who will ask it first. It's admin and admin.
I have to say, this is not a good practice. When you run it in production, don't use the same username and password, all those things. Also, don't share your passwords in a workshop like this, usually. Just saying.
It's fine enough to just
In 1 hour, the VM will disappear, so you can crypto mine for an hour if you want.
Okay.
So once you all connect, let me know and you can go to the next step.
I see one person connected. Who else is connected? 2 people, 3 people, 4 people.
Carlos, does it have internet access in browser?
Okay. Are we all connected? Should we? Oh. You're getting a network error, you said. Okay, let's see.
Sure.
We are lucky because we have the expert. Any other problems? You managed to connect? Connected? No, it's okay.
Let's go to there if you want.
Aaron, are you ready for your first full workshop?
Don't get his food in the problem.
Sorry?
And multitasking.
That's fine. I don't know. Only if you win at Jenga.
Here, connect now.
So the user
Yep.
Anybody having difficulties connecting at this point? Would you like some help?
Nope. I think in the back everyone was connected. What's next?
So once you log into the Kubeflow dashboard, actually, I can also do a little bit of this in parallel myself. So theoretically, you should land into this page. Is it accurate? So this is the Kubeflow landing home page, and right now, to make this simple, I've logged all of you in with an admin password that have access to namespaces from multiple teams. So to make this to also try to get as close to a real world example, I'll slightly divide you on like everyone until here will be team A. So if you go to the drop down, you should be able to click on the team A namespace. And the rest of you can be on the team B and you can be on team C. So
Can we make it a competition then?
which team will win? Ooh.
Yes.
So I will go with team A for a sec. And the first thing that we need to do is go and create a new notebook. So to do this, we'll have to go to the notebooks page and click on creating a new notebook. Now, please don't click launch yet. So first of all, try to create a notebook name. I would suggest for everyone to put their name as the notebook name to avoid any naming collisions when we try to create the notebooks. Still, don't create the notebook yet. We will select Jupyter Lab. You don't have to do anything about the image. The default one will be selected. The default CPU and RAM should be okay. You will get a new volume attached to your notebook so you won't lose your data. And this is the super important part all of you want to do before you click the launch button. There should be an advanced options. And from there, you can select other configurations to apply to your notebook. And I really, really want all of you to click on both Access Min.io and Access MLflow.
What's Min.io?
Min.io is an S3 solution that we run in Kubernetes, and it actually will contain all of our artifacts for the model, and it will be crucial for the notebook to be able to have the credentials to connect to it to store the model that will create while playing around. And I'll show you exactly in a sec what does that mean. So at this point, we can go and create a launch. Again, on the configurations, make sure you select both Access Min.io and MLflow. Oh, I see people creating. All right. Notebook. And at the end, advanced options and configurations.
A bit more now, sorry. One more now. Here. Advanced options? Can you?
Ooh. Team B is on fire.
Makes it very ridiculous for me not being able to see anything.
I can see why.
Notebook from mobile. Who's the adventurer? Who created notebook from mobile? No, you're not Team C. Who created the notebook from the mobile? That will be fun. Okay.
No, it should be.
You see why I'm lost?
Ooh. That will be interesting.
There we go. Oh. I had one thing.
Oh.
I'll go here. So if you go to advanced,
Right.
in configurations, you have to click also
There you go.
allow.
That was what we're missing.
Yes.
So both of those.
Yes, and then just ensure that you add a name because I think
It needs to be unique at the end. Thank you.
it's difficult to be blind. Okay.
Okay.
We do have plenty of notebooks created.
We might have an issue with the scaling though. I think I misconfigured something on the Kubernetes.
Is there anything I can help you with?
Oh no.
Mind if I could see? Also, charge my phone somewhere. Can I help you in any way?
So most probably, okay. Damn. No. Okay, I think we will have some small issue with the scheduling of the pods.
Why?
due to resources. I think I misconfigured the notebook of the microkits right now to not have too much to to allow for all the multiple notebooks created at the same time.
It has enough power, right?
Talking about hamster, it's gonna run out.
Oof.
Kubernetes will straight out.
Oh man.
Like AWS.
Then okay, I'll wait for 1 minute to see if.
So they might talk this.
It looks like you got yours. Oh, yeah, come on.
One stress.
Quick, look at PC.
If not, it's just to take.
Hmm?
If not, it's just to take events, for example.
Yeah, that's how it will happen. So, Aaron, you're the lucky one. We will use your notebook throughout the workshop. So,
And it's worth mentioning that at the end we have all these resources, so we can try it after as well.
on how to recreate. So the quick thing to check over here is, as we mentioned, the configurations, which again, it's Kubernetes, and we end up injecting into our pod with environment variables credentials about how to access MinIO and credentials for where the MLflow server is and how to talk to it. So with this, Aaron, thank you very, very much for your kind contribution. And we're going to use Aaron's notebook to take a peek on what we will run. So the first thing that we'll need to do will be to actually clone the example repo that we have, which is gonna be
I think it's because of resources.
yeah.
I think we can team up though. One thing that we could do actually is to try to delete some of the notebooks and maybe team up meanwhile. Oh, I see some of them also being created. Aaron, I think you can take Kimonas notebook now.
Sure.
No?
Ah.
Because Kimonas, here we see your notebook created as well.
Really?
Yeah, we see many notebooks created here at the end.
And they become green?
Yes.
Oh, maybe I'm having some huge delay then. Oh, these are volumes. Something.
Oh, true.
Yes, we're still on the.
There are two people that are lucky.
Okay, so back to Aaron. So we will turn our GitHub repo and we will go and use our branch, which is going to be the one and only Ubuntu Summit 2023. So, and with this, we can actually go and start to take a peek we're gonna use the specific notebook you have for UDS, and we'll start with a playground of a simple Jupyter notebook that we will run to do wine predictions. We'll start initially with clearing all the kernel and all the outputs. So we'll set our kernel. And the first thing that we'll do, I mean, aside from installing any dependencies we need, for the people who managed to get access to a notebook, please make sure to update your user values so that we can all use different artifacts. Oh man.
It's okay. I think we can do it using the notebook, and then we give access to the resources, and we invite everyone on Mattermost to ask us questions.
So I see the same thing that you typed in Central. So I think we can do it like.
What do you mean?
I see the git checkout command. So
Are you on Aaron's notebook?
yes.
Woohoo!
Yeah. They're on the same notebook. Yes. No, theoretically.
It's not going to be.
No, because we don't have enough resources.
So the first thing that we'll need to do is actually go and fetch the data.
Different notebooks.
And we're going to use a simple request library, but as I mentioned in the beginning, the data could potentially live in any data warehouse like S3 or MySQL. But in this case, it will be a simple HTTP request to go and fetch it. So by that time, we should get a file for one quality, which will contain our data. And the usual way to check around this data is actually to load it with a framework like Pandas. So we'll go on and take the data that we just saved and take a peek through Pandas. We can see the different columns like the acidity, the volatile acidity, the chlorides, the density, the pH, and finally, what we want to predict, the quality. We'll do some minor changes on this data set to add some underscores to any spaces because that's easier to us to work with. And we'll end up creating a small function, a pre-process function to go and try and load and clean our data set. And to test out that this function is working, we are actually going to run it and tell it to just produce a final Parquet file that will include the produced pre-processed data set. So again, at some point, we should also see the folder for a Parquet file. So this is when the next piece happens, where we're actually going to look into training a model. And first thing that happens is we import all the libraries that we'll use. As I mentioned, this is a quite simple model, and we're going to use an almost ready one, which is the elastic net linear model. And here we're actually going to then write our code that will load the preprocessed dataset we created. And we will just split this then into a training dataset, a test, and a test dataset. For those that don't really know what this means, it just means that a subset of the dataset will be for training, that we will feed it while training, and the test, and we've excluded the quality column, which is the one that we want to use for predictions. So with this, we'll define our model with some parameters and go and fit it based on the training input data and predictions. Now,
Kimonas, I have some questions. Do we always have the same parameters values?
man, you really got one step for me. So that was a very good question. This time I used a pretty simple model, and I also, as a god, found the correct values I should use out of my head. But a lot of the times, this is not the case. And what we actually need to do is be able to have a way to experiment and find out what's the best set of parameters to use for my model. So while this is a simple one and didn't go to that route for now, Kubeflow also has a component for being able to handle this, which is actually AutoML, in which we create experiments and define exactly that. We define the search algorithm. So we have our different parameters that we want to find what's the best value to use. In this case, let's say we have those three: alpha, L1 ratio, and random state. So those variables actually construct a search space. So we need an algorithm to start searching throughout this complex space of different values of the parameters we define. We define what's the objective to maximize or minimize whatever we want to have. We define what the hyperparameters are and their ranges so that we can do the training, and then define the template, which will end up being a container that will have the training code, so that it will at the end of the day go and spin up a ton of different pods that will go and run models with different parameters until we find the best parameters, which after we have them, then we know, okay, it's this set of parameters. But to Andrea's point, I skipped completely this point here and consider that I've already done my hyperparameter tuning, and I know that this is the best set of parameters that I need. Any questions at this point?
We have 4 minutes left.
Really?
Yes.
Oh.
Oh.
Right.
Oh, my bad. We have actually 30 minutes left.
So we'll be getting an input error that my arrow is missing.
And what error?
Do you want to say it out loud
Oh.
so everyone hears it? Sorry.
I'm just getting an input error. So it can't. There's no pi-arrow dependency. It's a missing dependency trying to run the script.
We can ignore this specific one in the beginning.
Okay.
This specific version, it didn't really matter. I had to fix it in the in the morning, but it missed me.
Oh, it's not that one. It's further down during the
pip install.
during the training step.
Oh wait.
Yeah, there's a big red box, and it's saying yeah, pi-arrow.
That's practices with data scientists. Oh dear.
Oh, were you running the steps one by
Yeah,
one?
one by one. Yeah.
Don't worry, and you run it now. Well,
So if you, I created
the one.
the CSV, and then I just did the next one. I just after I downloaded the data, I just did pre-process. I did and then
Did you run this one?
maybe not. I thought I did, but maybe I missed it.
Does he know anything with Jupyter notebooks?
Maybe I did. Yeah, maybe I skipped the. Maybe I missed the setup.
Let's see.
I think you could be right.
Okay. So yes, that was it.
Yeah, I missed the step. Thank you.
Maybe it's an important learning. Don't skip steps because then it will likely fail. No, but I think the obvious things are the ones that get us in trouble when it comes to ML. Let's go back to you, Kimonas.
So I don't have 3 minutes left, right?
Now we have 30 minutes left.
So for training the model, as we mentioned, we converted this. We saw the training. Yeah, I think I'm gonna run it. Oh well. And we run the fit function of our model on the training data set with the outputs. And this actually creates created the model, which then I can use and predict the test data set, for example. The test data set is just like the trained data set that has multiple columns, and we try to define the quality of the wine. So we actually created now a model, but the next question is, okay, I've created my model, but creating a model is the first step. At this point, what we always will end up doing is, okay, how do I track what model from all the values that I played with is actually the best one? And this is where MLflow comes into play. And
I have a question here. Sorry, I'll cut you off again. But do we know what's MLflow in the room? No, what's MLflow, you say?
Oh, good catch. So MLflow is a system for being able to track models. Models doesn't have anything dedicated. There's nothing specific to ML models. It's a system where it has a MySQL database for keeping some metadata and an S3 for actually storing the actual files. And MLflow looks like this. This is the MLflow from the same instance, in which it breaks down things as experiments, and an experiment can have multiple runs inside of it. Now we're using the default experiment.
What's a run?
A run is kind of self-explanatory, I would say. No, I'm kidding. Which a run is the concept of something that ran and produced some artifacts. So this is how MLflow can really nicely couple with the pipeline concepts that we'll see in a sec, because pipelines also break down its concepts with an experiment that can have multiple run. You essentially have a pipeline definition that you can use then in any experiment and retrigger this pipeline as multiple runs, but with different parameters each time. So to actually see in live how we can use MLflow.
I could take this and just.
That's, yeah. So we will define, in order to use MLflow, it's quite straightforward. Keep in mind though that if you remember from the beginning, from the notebook that we created, we explicitly, there was another notebook that got created. Okay, so we're happy to have as many folks. If you remember the actual notebook that we created, we have injected information about MLflow, which MLflow would need to be able to talk to know from inside the pod that, okay, so this is where I talk to MLflow. And those environment variables ended up getting injected because we selected those configurations. So if I see the pod that ended up getting created for my notebook, we will end up see those environment variables both for AWS as well as for MLflow. So this is why out of the box now, we can use MLflow SDK. And as you can see, we will create a run. The name of the run will be my name plus for the specific model. It's fully up to us. And with this MLflow run, I'll actually recreate my model, train it. And once the model is trained and trained, we were going to log this model into MLflow. So if we run this step, it will take some time because it's training the model, although the training is not that big. We will see that the training finished and we logged our model with this URL. So for those that are still following, if you go to the same IP and /MLflow, which is where our model tracking is, you can actually see that if I refresh as well, 24 seconds ago, we had, is it Juan?
Juan Luis is there.
Nice. So we can go and see at this, for example, Juan's run that went and created actually, it had some tags, who's the author, it's Juan, because we've also configured it in our code, who the author is. We can add any other tags that we want here to add special information, metadata to our run. And this run had those parameters. We can see the alpha, the L1 ratio. Yes.
No, I don't have a question, but I would like to add here that it's very useful to have those tags, especially if you work in a bigger team or in an environment like this, such that you easily define, understand. You can easier collaborate as well between people.
Exactly. And this is the metadata of the model, the metrics, the parameters, as we discussed initially, that this also, to keep in mind, lives all in MySQL. And there is the URL and why we have S3, which is actually where the model itself now is being stored, the final artifact. And yep. Yes, the model, I mean the actual file that got produced. This is an artifact that we need to save somewhere. We cannot save it in. This is exactly what we save. The model gets saved into the artifact store, S3, and MLflow has some metadata in MySQL that says, yes, this is the produced model with those metrics, those parameters, and it lives in this URL. So if you want to go download it, it's over there. Of course, what we can do is, if I want, I can just change the parameters and play around. And this is how we'll end up with multiple runs and having different versions of a model. So once this will run, we will now see that if I go back to my experiments, my experiment got updated 10 seconds ago. And now my produced model has also changed. Say there should be also a version. The version is also here. So this is how we can also track in MLflow. MLflow is able then to track multiple versions of a model. Model PKL file and everything we have. So, yep.
Do we have questions? Yes.
Is there a way to compare two versions of the same model on MLflow? For example, so we can see which one.
That's a good question. I think there should be for sure a way. I know how to do, you can do it with the CLI for sure to be able to search them, but I'm not sure if you can do it also with the UI. I expect to be able to do it with the UI though, to be honest. If you go to the models, oh yeah, you can also see the version.
Here you can actually edit this view to see all the, to have a UI basically that helps you out and easier compare models.
And So, yep.
Yes.
It happened a little bit more at the beginning. Over here. Where from the initial data set, from the whole data set, with this function, we split it into train and test data sets.
Yes, there is a question there.
Because when you create, this is at the end of the day an algorithm that doesn't know, that gets your training data, like these are my features, this is the acidity, this is the chlorides, this is the density, and it needs to be able to predict what the correct output of the quality is. Now, when I'm training my model, initially it needs to know, okay, so these values are matched, should correspond to this value. But in order to be able to judge if a model is actually good enough or not, after we do the training, we need to evaluate it on a new dataset that it hasn't seen.
It's basically to ensure that if your model performs accurately such that you could take it beyond experimentation. Yes. Yes. Good catch.
And there are also different mechanisms for when you create your training and data set to actually play around with different combinations. So break the whole data set in different ways for train and test and be able to find the best one with this process. But I get it super simple here, but good question.
Simple for you.
So at this point, we have played around a lot with our models to train them, and we have also stored the best one in S3 via MLflow. So then the last question is, how do we go then to deploy an actual model server at this point?
Before we get into that, can I ask you why do we deploy models? I'm here just to ask the obvious questions.
We deploy models because the whole point, as we mentioned in the beginning, for MLOps, the whole value you get out of it is to have this live server running and doing the predictions. So all of this happens so that we can end with a deployment that will have our model and will be able to get queried and get responses for the requests.
Maybe I would also like that to add that not all models you create will be deployed, and it's very important.
That's true. So for the sake of science, let's spin up one. We're going to use Seldon over here, but Kserve can work as well.
What's Seldon?
Seldon is a toolkit for deploying inference servers. Inference servers are any regular server as you can expect, but with the difference that it contains some specific runtime inside of it, so that it can load the model and be able to run a server that can understand. So this is my model. Let me load it so it can answer back requests.
And what's Kserve then?
Kserve is also a similar project that aims to do the same. So depending on your preference, you can either pick one or the other and go. So this is a Kubernetes YAML. So this white might seem a little bit scary, in which we will define our Seldon image. And the important piece is that we define the model URI that we want to use, which actually is an S3 endpoint that contains the model. And with this, we put it all into a function that will load the necessary Kubernetes APIs and create our Seldon deployment object. So without further ado, let's go and create a Seldon deployment that will use the MLflow server image that can go and talk to MLflow and get our model from this URI that we got from the latest active run that we had. So let's give it a go and run our deploy function with our default arguments. And here it looks like it failed because I had already created this before we started the demo. I couldn't hold myself. So this is my Seldon deployment, and we can also see that by getting the pods in our namespace. And we're having the same problem with resources, so we cannot actually start the server. Damn. Let's confirm. And yes, it's the same one that for now we're getting too many pods with preemption. So unfortunately, we'll not be able to see this live at this point, but once we would have the model server, we could actually go and once the deployment would be ready, then all we need to do is create an HTTP request and send this request to the model server. Excuse me, where? This is an example. This is an example row that we could have. These are the same rows. Exactly. Yes. Where now a user says, "Okay, now I have this wine. Tell me what does it do." So this is how the different parts that we would use. And let's delete actually since it doesn't start. So at this point, we've done the experimentation from inside the model to play around and be able to find a notebook a model that works for us to fit our needs. But as I mentioned, the true part here of using Kubeflow comes from now that we've experimented with our notebook, the important part is to go and create a pipeline out of that notebook. So the way that this is going to work is very, very similarly on initially is about converting the code that we've run and know that works into an actual pipeline. So let's do it together. And first of all, we will again load all of our imports. This time I put them all to the beginning. The important part here is that all of this is orchestrated by a client object inside of the notebook. So this client object will be the one responsible for spinning up the pipelines. We'll make sure that IO had a bucket, and now we're going to define the same thing that we did while playing around, but the difference is now that we're going to express our code as Kubeflow pipeline components so that this can be automated. The first step that we need to do is always go and fetch our data. In this case, if you remember correctly, we defined our URL and went and made a request to download the data. But how do we convert that into a Kubeflow pipeline step? So in this case, we are a little bit lucky because the actual upstream pipelines community has defined a component definition that actually goes and downloads a file. So this is the DSL. It's Argo at the end of the day, where you define what are your inputs and what are your outputs. Our inputs are the URL that we would like to use, and the output is our actual data. And as you can see, it's a simple image with Alpine with curl that just goes and curls the file that we defined. So in this case, we were lucky because it was quite straightforward and we need to just download the file. But if that would not be the case, we might need to construct a component and say, use this container that would contain the logic of going and downloading the file. So then the question is, okay, so this is a step that goes and downloads the file. If I define then my next step, which is going to be my pre-process, as you can see, the pre-process is the same process that we defined previously, but the definition is very slightly different. So while this is the initial function that we had, now we convert it into a KFP function by specifying that our file path is actually an input path, and we have an output file which KFP understands. Now, what does this all mean? This means in our graph that the first step of our workflow, and this is defined inside of here and you don't see it, this is actually going to end up producing a file. The magic of Kubeflow pipelines and why we like it from a data science point of view is because it gives us an easy way to define our steps and how the data should be passed among those steps. So over here, my downloader is one step and my pre-process function is another step, but my pre-process function will need a file that was downloaded from another container. Now, for all of you, keep in mind that, again, every step is a container of its own. What Kubeflow does with these annotations on the variables is telling Kubeflow pipelines and the underlying execution engine, which is Argo, that those files will end up, before going through each step, be transmitted either via some annotations or most of the case, because we have files and they're big, via an S3 endpoint. And all of this happens completely transparent to the user. And this is why KFP helps data scientists, because under the hood, for this inputs path, what this happens is Kubeflow pipelines will spin up your container. It will go and find what was your previous step, download all from S3 all of the output that was produced from this step, create a file for you, and at the end of the day, will call your function with just the name of the file that is on your new container. So this is why Kubeflow pipelines are powerful for data scientists, because they allow them to, they give them the execution of being able to run different containers, but hide from them the details of how to have to pass all of those files from S3. So that's why in this case, all of this magic happens under the hood because I used KFP components input path to mark the type of my input variable. And then I'm running, I have my logic inside of my function. Keep in mind that because this function will end up as a container of itself, we need to include any import that we would need for the code. So that's why we do import pandas here, and it cannot automatically found an import that was created somewhere in the notebook. Anything that we defined here, this function and only this function, is what will end up running from our SDK. So this is now where we can go from the Python code to the Python KFP component, and we're using the KFP CLI to create a component, which is actually the definition of like a container with its inputs and outputs, from a Python function. So as you can see, we defined that, yes, preprocess is the function that we will use for running in this container. We will also store this for a file to play around and document, but this is not always necessary. And we define the base image and the packages that we want to be installed in this base image. So that's why it's automatically this will end up creating. Actually, let's see it. It will end up looking like this, where we define our input and our output. And at the end of the day, what it went and did is it's a container, it's a container for a pod spec, where the Python image is what we defined. And KFP went and injected some codes to go and download the packages that we defined over here. And then went and actually does also what we discussed about the file handling, and then ends up calling our function with those files and return the outputs and handle them accordingly. So this is how most of the cases we end up going from the code inside of a notebook into a pipeline step as a container by defining the Python and the code that we wanted to execute. And the same exact thing happens also with training. Now, training will be a dedicated component of itself. And what is its input going to be? Its input is going to be an input path that will be produced by the previous step, the pre-process, which will have an output file, an output path of type Parquet. The Parquet is the type of the file. And the training will now get this file with, again, everything that happens under the hood. Argo and pipelines will pull the data to S3 and we'll download them to the new container, and all of this completely transparent to the user. We define all of our imports inside, and then we define the training code that we had for splitting the data set into training and predicting. And with MLflow for each run, we will also log the model, and at the end of the day, return the URI of the trained model. And this is the output of the training step. So let's create also a component out of this. Now we'll training it locally as well to verify that it works. Yes. So the same way we create now our training component with our function is the training, and the base image is Python 3.8, and the packages that we had to install are slightly more this time. And the same as previously, we created the YAML to just be able to inspect. It's the Python image that will go and install all of our packages, and we'll end up running the code that we defined. And with this, we're almost ready to conclude. And we will actually create the last step, which is the deploy function that we previously saw for deploying a model server. But this time we're going to actually create to have a dedicated component function just for deploying the model server as well. And with this, before we're almost out of time, I will only show you the meat of pipelines, which is how to create the pipeline definition, which again, we'll use the DSL. And what happens is over here, we'll define our tasks. And for each task, we now define the inputs of the task. For the web downloader, we needed the URL, so we defined the URL parameter for that component. This was the input of the component that we saw. For the preprocess file, for the preprocess operation, for example, it needed if you remember, the preprocess needed an input because we have a file path as input. So when we define the pipeline, this is actually where we define, okay, so for this step, you will take your input from the outputs of the previous step. And same thing for the train task. Your file input is going to be the output of the preprocessed task to run. But over here, we will also inject some environment variables for MLflow that we know that we need for the train step to be able to talk to MLflow and access min.io. And last but not least, the deploy our model server. And again, the input is going to be the train task's output, which is the model URI. And with this, we're actually going to compile the pipeline. Oh, I think I didn't run.
Or not.
Wait. Oh, I didn't run the initial component.
Do you remember my very basic observation? Don't skip steps.
You have a run book together with all this?
Fingers crossed. Yeah. And we actually end up we run and create the pipeline, which
How
now
can we
gives
see
us,
pipelines?
let's go. So we can see our run, which is actually now the pod that we defined, the first that downloads the data, but we're hitting the same problem of getting too many pods. Really apologize for that. So we will not be able to see the pipeline complete as well, but since we're almost also out of time, I think I really like to show you the end of how the 4 steps will be, but most probably today will not be your lucky day, but in 10 minutes, maybe I'll have fixes, so hopefully we'll see something. So this is how it all ties together. And to get it also back to the presentation, hopefully to give you, again, a holistic view of the things that we learned is, at this point, what we play around is what are the different Kubeflow applications. And in this case, we play around with MLflow, with notebooks, and with pipelines. We took a look on how to be able to create a notebook, and then from inside the notebook, run the full life cycle of a model of creating it, tracking it with MLflow, and deploying a model server with the actual model, and then going also from a notebook to a pipeline. So thank you very much. And
should we go to the last slide with resources while we get some questions?
Of course.
Maybe let's present it slideshow. Cool. Do we have questions? No more questions, I see. Maybe I'll add here that Charm Kubeflow, it's an open source project as well. The example that Kimonas shared, it's available for everyone to try it out at home with your own rhythm, with no resource challenges. And then if you hit into problems or you would like to give us any feedback, we are both on Discord or Mattermost. You find Kimonas there. I mean, you find both of us. But whenever there is a technical problem, I will go to him and, hey.
And I will probably ignore you.
Yes, there is a question there.
So like the main agenda with Charm Kubeflow is only with MySQL, or can it be different source?
Can we use any other data sources except for MySQL? The answer, I mean,
yes, and that's why one of the group with, at least for Charm, you can use it from anywhere. As long as your container can access it, you can use anything you need. So then you can scale that.
Yes, you can use that. Basically, you can use any data source that you like in order to build a model, and also it can connect to different types of data sources. We ran some demos in the past with LLMs, so we would use also vector databases that connect to Kubeflow as well. So it really depends on your use case. You can stream data from wherever. Do we have any other questions? In this case, I will say thank you all for joining us.